In part 1, we covered basic probability. Today, we mastered the laws of probability. Students often struggle with when to add and when to multiply. So, to make these principles stick with total ease, I'll put the rules into a song. Listen to the lyrics closely because they contain the secret code for the entire lesson. Let's vibe.
Yeah.
Ezikan on the beat.
Let me teach you something smart now. Master the laws of probability with Ezikan song. Additive law, such as when you see or know that you will add. Multiplicative law, such as when you see and know that you will have to multiply it. Oh yeah! It's easy, just add with or multiply with and. Yeah, you get it now.
The core concepts. What are these laws? Number 1, we have additive law. Additive law. Use this when you have choices. That is, you have more than one alternative to choose from. You either go for option A or option B or option C. It is about combining your chances. Remember the song says, when you see or, you add up. So when you see or, that is probability of event A or B to happen. No, you either have A or B and not both. Remember the song says, when you see or, you add. So it will be the sum of their separate probability. Probability of A, probability of event A, plus probability of B. Probability of B. When you see or, you add. The second law we are going to look at is multiplicative law. Multiplicative law of probability. So use this for a sequence. You want one thing and then another thing to happen. It is about a chain of events. By chain of events, I mean joint events when they occur together. Remember the song says, when you see and, you multiply. When you see and, you multiply. So, for multiplicative law, that means probability of A and B to happen. It will be the product of their separate probability. The song says, when you see and, you multiply. This is for independent events where one event does not change the other. So remember, 2 events, we want to have both occurring at the same time. Then we want to look at different events in probability. Let me call this 3. Mutually exclusive events. Mutually exclusive events, no overlap. No overlap. Mutually exclusive events are events that cannot happen at the same time. Events that cannot happen at the same time. It means you either have one of the several events to happen. If you have 2 events, you have either event A to happen or event B to happen, and not both, either A or B. So by no overlap, it means they don't have anything in common. Nothing is common between the 2 events. So I've told you there are events that cannot happen at the same time. If you have 2 events you want to consider, maybe let us say you have event A and B. You have probability of either A or B. So that means or will be used in that case. Remember the song says, when you see or, you add. Therefore, for mutually exclusive events where there is no overlapping, probability of A or B to happen will be probability of A plus probability of B. Remember the song says, when you see or, you add. Number 4, we have non-mutually exclusive events. So the one to consider here is overlap. Remember, what we have considered here is no overlap. This case, they will overlap. These are events that can happen at the same time. There are 2 or more events that can happen at the same time. So one either happen or the other or both. You may have one event or the other event may happen or both of them. So the both which may happen, they have something in common. By overlapping, it means something is common between the events. So they have something in common. That is what overlap means. So probability of A or B. Remember, all in probability is plus. That means probability of A plus probability of B. Since they have something in common, you have to subtract the one they have in common so that they won't coincide. You have to remove the one they have in common minus probability of A and B. Remember, probability of A and B and is multiplication. So that means we have probability of A plus probability of B minus probability of A times probability of B. So they have something in common. That is what we mean by overlap. So when something is common between them, you remove the one that is common. Remember, in set notation, probability of A or B will be probability of A plus probability of B minus probability of A intersection B. So these are the laws I want you to bear in mind. Example 1. A ball is drawn at random from a box containing 8 green balls, 5 yellow balls, and 7 red balls. Determine the probability that it is A, green, B, yellow, C, red, D, not green, E, green or yellow. Let's have the solution to the question. Solution. So number of random from a box containing 8 green. Number of green balls. You have 8. Number of 5 yellow balls. 5. And 7 red ball. Number of red ball. You have 7. So total balls. We have 8 plus 5 plus 7. So that will be 20 balls altogether. You have 20 balls. Remember, probability of an event, probability of events to happen. Let's say the event is X. The formula is number of required outcome over total number of its possible outcomes. Number of required outcome over total number of its possible outcome. In the A part of the question, you have to determine the probability that it is green. In the A part of the solution, probability of green balls. How many green do we have? We have 8 greens altogether. 8 out of how many balls altogether? Number of required outcome, we have 8. Total number of its possible outcome, we have 20 balls. 8 over 20, that gives us 8 divided by 20, that gives us 0.4. So the probability that it is green, it is green balls, is 0.4. In the B part of the question, you are to determine the probability that it is yellow. Probability of yellow balls. How many balls are yellow? We have 5 yellow balls. Number of required outcome, 5. Out of how many balls altogether? out of 20 balls. 5 divided by 20, that gives us 0.25. That is the solution to the B part of the question. Then after B, we have the C part of the question. In the C, you have to determine the probability that it is red. Probability of obtaining red balls. How many balls are red? Number of required outcomes. We have 7 red balls. Over total number of possible outcomes, we have 20 possible outcomes. So over 20. 7 divided by 20, and that will give us the probability of obtaining red balls. So we have 7 divided by 20, that gives us 0.35. 0.35. In the D part, you have to determine the probability that it is not green. Probability that it is not green, D. Probability of not green. I've told you that if you want to calculate the probability of the opposite event, that is, you are told not something, opposite event, you take that probability of that event, you subtract it from 1. Probability of not green will be 1 minus probability of green, which is 1 minus probability of green. How many green? What is the probability of green? You have 0.4. 1 minus 0.4, that gives us 0.6. That is the probability that it is not green. How many colors do we have in the question? We have green, we have yellow, we have red. And in the D, this is alternative way of solving it. Probability of not green. If it is not green, how many colors do we have? We have green, yellow, red. If it is not green, that means it could be probability of. If it is not green, it could be yellow, or it could be probability of yellow, or if it is not green, it could be yellow or red. Probability of not green, that means it could be probability of yellow or probability of red. Remember the song, when you see or, you add. Therefore, probability of not green, probability of not green, which is yellow or red, which is probability of, this one is equal to probability of yellow plus probability of red. Now, or you add. Probability of yellow. What is the probability of yellow? We have that to be 0.25. Plus, what is the probability of red? Probability of red is 0.35. 0.25 plus 0.35, that gives us 0.6. Therefore, the probability of not green equal to 0.6. That is the alternative way of solving that. The last question under this, you have to find the probability that it is green or yellow. The E part of the question, probability of green or yellow. The song said when you see or, you add. That means it will be probability of green plus probability of yellow. And remember, the probability of green from our solution, we got that to be probability of green is 0.4, and the probability of yellow is 0.25. So that means 0.4 plus 0.25. That will be the probability of green or yellow. Probability of green is 0.4 plus probability of yellow is 0.25. So if you sum them up, therefore probability of green or yellow equal to 0.65. Example 2. If the probability that Dayo will be alive in 20 years is 0.8, and the probability that Toyin will be alive in 20 years is 0.3, what is the probability that they will both be alive in 20 years? Example 3. Suppose that a box contains 5 white balls and 4 black balls. If two balls are to be drawn randomly, one after the other, without replacement, what is the probability that both balls drawn are black? So we want to start with solution to number 2. Remember, you were given the probability that Dio will be alive in 20 years. Let's take that probability that Dio will be alive to be P of D equal to 0.8. And the probability that Tony will be alive in 20 years, let's take that to be probability of T, P of T to be 0.3. We want to find the probability that both will be alive in 20 years. So to answer that, so what you do is solution to example 2. Solution to example 2. We have probability that Dio will be alive. Let's take Dio to be D. Dio. D. Tony to be T. Probability that Dio will be alive in 20 years, that is given to be 0.8 in the question. And probability that Tony will be alive in 20 years, that is given to be 0.3 from the question. And the question asks you to calculate what? The question asks you to calculate the probability that both of them will be alive in 20 years. That is probability that Dio and Tony will be alive in 20 years. Both of them will be alive. That is, remember we said and. So since it is both, that is a joint event. Both there shows that it is a joint event. And I've told you that for a joint event, you are combining them with and. When you see and, remember the song, when you see and, you multiply. So we have probability that Dio will be alive times probability that Tony will be alive in 20 years. Now, probability that Dio will be alive in 20 years, that is given to be 0.8 times probability that Tony will be alive to be, that is given to be 0.3. The product of the two now, therefore probability that Dio and Tony will be alive in 20 years, if you multiply them, you get 0.24. So that is the solution. Suppose that a box contains 5 white balls. So let me have solution. White balls. Balls. Let's take that to be W. And 4 black balls. Black balls. Let's take that to be B. And you were told number of white balls. How many are white? Suppose that a ball contains 5 white balls. 5. And 4 black balls. Black. Number that are black, we have 4. If 2 balls are to be drawn randomly one after the other, so what is the total balls now in the box? Total balls. That is the total number of possible outcomes, which is 5 plus 4, and that is totaled 9. We have 9 balls all together. Since we have 9 balls, now the question says, if 2 balls, remember, if 2 balls are to be drawn randomly, one after the other, without replacement, what is the probability that both balls draw are black? If you draw the first black, probability of first black. How many are black? We have black balls, 4. 4. Number of required outcome, 4. Out of total number of possible outcome, the total is 9. If you draw the first black from the box, the probability of obtaining the first black will be 4 out of 9 balls. Remember, you have 9 balls. You have drawn the first black and you have this. So you'll be left with the remaining your white. White still remain how many? 5. Black now remains how many? Since you have drawn the first black and you got that to be 4/9, so you will still be left with 5. You have not drawn any white. Then the black that will remain in the box, draw me, you pick to draw me to pick. If you pick one black, the probability of picking that one black ball is 4/9. Then you'll be left with 3 black balls in the box. You are left with 3 black balls in the box. Now, what will be the total number of balls in the box now? Total now will be total balls will be 5 plus 3, which is equal to 8. You have 8 balls left in the box. Now that you have 8, remember the question says randomly, one after the other without replacement. Because they didn't replace it back, that is why you were left with 3 balls, 3 black balls. If it were replaced after drawing it and you put it back, then the black will still remain 4. But now, since after you have drawn the first balls and you got the probability of 4/9, then and you did not replace it back, that means the number of black balls you'll be left with will be 3, no longer 4. The whites will still remain 5. That is why you are now having 8 balls altogether. Comprises 5 white, 3 black. Now, without replacement, what is the probability that both balls draw are black? If both balls draw are black now, so remember you have drawn the first black now. Probability of drawing the second black. If you want to draw the second black, how many black do you have? 3. Out of how many balls? 8 balls altogether. Now, remember the question says both balls draw are black. Probability, that means if both are black, you have the probability of first black, second black. Now, probability of having both balls black. Both balls draw black. If you want to have both to be black, that means you have the probability of first black, second, and second black. If the first is black, the second two will be black. First black and second black. Remember the song, and in probability is multiplication. Probability of having the first black is 4/9. The probability of having the first black is 4/9. While the probability of second black is 3/8. So we have 4/9 times 3/8. First black 4/9, second black 3/8. So we have 4 times 3, that is 12. So 9 times 8, that is 72. 4 times 3, 12/9 times 8, 72. Therefore, 12 divided by 12, that is 1. 12 in 72, that is 6. Therefore, probability of having both black is 1/6. It's all in the reading. Or add and multiply. Mastering these 2 rules is the foundation of everything in statistics. We are going to master the conditional probability in the part 3. If this song helped you, hit the like button and subscribe to Ezikan Academy. Comment next for the next lecture. Thanks for watching.